Welcome to the Virginia Education Center for Asphalt Technology. This is the VDOT Materials Certification School for Surface Treatment. And in this module, we're going to go through some basic math problems that you as an inspector or as a contractor will have to be able to work out in the field when you're doing surface treatment projects. Some of the things that we want you to understand through this module is how the distributor speed impacts the project, how it impacts the number of gallons per square yard applied. We'll talk about how that all relates together. We're going to talk about different application rates on these projects. We're going to talk about application rates of the aggregate, how we're going to compute the amount of material needed for a project, and how to fill out some standard VDOT forms. These forms will help you determine how much aggregate application rate went down, how much asphalt or emulsion application rate went down. So we'll walk through all of these to make sure you're comfortable with the common math as well as a few other things out on the projects. So how do you know? How do you know that chip spreader is really working? Yeah, it's spreading rock on the ground, but is it at the right application rate? Is it at 16 pounds per square yard or 15 or 17? How do you confirm your application rates? How much material do I really need for a site? So all these things go into the things that we look at out on these projects. So first, let's just start with estimating project quantities. How much emulsion, how much aggregate do I need? Well, what do I need to know to compute these things? Quite simply, how long is the route? Is it a mile? Is it 3 miles? Is it 7 miles? How wide's the road? Some of these roads vary in width, so you have to take that into account. Are there any cul-de-sacs? We use a lot of surface treatments in some subdivisions. Subdivisions sometimes have cul-de-sacs. How do you figure out how much material you need in the cul-de-sac? What if you got a tie-in? How far do you tie back? Do you even need to really worry about that little bit of material? Really depends on how that project's set up if you need to be concerned with it. When we're calculating rates, there's a basic formula that you need to keep in mind, whether it's asphalt emulsion, aggregates, a lot of things. This basic formula comes in very handy. So rate, and in most all the instances we're talking about, if it's emulsion, it's gallons per square yard, or if it's aggregates, we're talking pounds per square yard. But typically we talk about tons of aggregate, so we have to make sure we do our conversions. Rate, so on a surface treatment project, we're talking about how many pounds per square yard did we apply? How long is that road? How wide is that road? And then we calculate rate once we know the number of tons we used. So, basic formula, length is in feet, width is in feet, 9 converts from feet to square yards, and T is in pounds that we need to probably, we know we use, say, 600 tons. We need to convert that 600 tons to pounds to use this formula. It'll make more sense as we walk through some examples, but just remember this basic equation, and we can rewrite it to figure out tons as well. Again, we look at that same type of basic equation, just rewrite it, and now we still have application rates, so how many pounds per square yard did we use? What's the length of the road? What's the width of the road? And we'll calculate the number of pounds of aggregate we actually use. So let's talk about this a little bit more in detail in a few slides. For emulsion, same type of thing. Now we're calculating number of gallons. So we drop that 2,000 that we saw here out because that just converts us from pounds to tons. We don't need that. So we know how many gallons. We just have our application rate, how many gallons per square yard, length, width, and 9 again converts us from square yards or square feet to square yards. So let's look at a project and how we would estimate how many gallons of emulsion we need, how many pounds of stone we need. Let's make it nice and simple. So route, modified single seal, 3 miles long, no cul-de-sacs. It's 22 feet wide. Our contract calls for 15 pounds per square yard of cover material. So how many tons of aggregate do we need? First thing, don't forget, you got to convert miles to feet. So we got 3 miles, and there's 5,280 feet in a mile. So let's go back to our useful formula. We're calculating how many tons we need. We know our application rate, so it's 15. It's 3 times 5,280, because that converts that over to feet lengthwise, 22 feet wide. When we plug it all in, 15 times 3 times 5,280 times 22 divided by 9 times 2,000, you should get 290.4 tons. So that's how much rock, how much cover material you need on this project. Do it again. A little bit different, but now we're calculating how much emulsion do we need. So we know that it's 2 miles long, a seal treatment, it's 22 feet wide. The emulsion calls for 0.2 gallons. Again, we got to make our conversion. So convert 2 miles over 10,560 feet. Plug everything in, so R is 0.2. Length is 2 times 5,280. Width is 22. Divide it by 9 to take it from square feet to square yards. And we need 5,162 gallons of emulsion, based on what the contract calls for. So that's what we're planning for. If we have a cul-de-sac, it's a little different, but all we're having to do now is account for the material that goes in that cul-de-sac, because now we're not dealing with a nice rectangle, where really it's a rectangle plus a circle on the end. It's not going to be a perfect calculation. It's going to be a good estimation of material. So if the road's 4,200 feet long, and this road is 18 feet wide, but we have a 20-foot radius cul-de-sac at the end, how many square yards of double modified seal are applied? So let's just walk through the equation. First, let's calculate the area for the rectangle. That's just length times width. Now, the area of a circle is defined as pi r squared. So pi is 3.14159, and we said r in this instance was 20 feet. So let's take this area plus this area and divide it by 9 and see how many square yards we come up with. So for that modified double seal, it's 4,200 feet times 18 feet wide plus pi times 20 squared, the radius squared. We divide all that by 9 and we should have 8,540 square yards of material for application. So now we've figured out how much area that we have. Now that we know for estimating purposes, let's check the application rate in the field of our aggregate and our asphalt. Because again, we just went through this process to estimate how much we need. Now that we're getting ready to do the project, let's see what our equipment is applying, because we need to go back to the contract and meet those specified rates. VDOT developed this pretty nifty little form that allows us quickly to do some calculations. You can tell if it's the first, second, or third course, it's the block coat. But if we're looking at the asphalt emulsion, what we need to know is what's the weight of the plate or the weight of the pan before we apply asphalt, what is it after we apply the asphalt, and this 8.14 is a conversion. That's how many pounds are in a gallon of asphalt. So it's just a little bit higher than how many pounds are in a gallon of water. So this just converts us from pounds to gallons. We have weight with asphalt in our pan or on our plate minus the pan or the plate without any asphalt. Multiply it by 9, divided by 8.41, and it gets us over 2 gallons per square yard. And what this is assuming is that our plate or pan is 1 square foot. Then we have the aggregate. So we can also just take it that next step that we have the aggregate and an asphalt emulsion on a plate or a pan. This is the weight of that same pan that everything's put in. B and A are the same as above. That's where our asphalt emulsion is. And calculate pounds per square yard. So we're going to walk through this as an example or two just to help you understand the math. So the inspector has a pan or a plate that's 1 foot wide, 1 foot long. The pan or plate weighs 2.875 pounds. So we've set it on the scale and we've recorded the weight. The distributor drives over the pan or plate with the asphalt in it and now weighs 3.037 pounds. So we've added weight through that emulsion. What is the application rate for the emulsion in gallons per square yard? So our rate is B minus A times 9 divided by 8.41. Or if we look back, it's this part of that sheet. So B is 3.037. A is 2.875. 9 just converts it from square feet to square yards. And 8.41 takes it from pounds to gallons. When we put all this into our calculator, our rate is 0.17 gallons per square yard. So again, looking at that, now let's look at the aggregate. So now, still got that same pan or plate. It still weighs the same. But now we have another pan or plate that weighs a little bit differently. They're not all going to be perfectly the same weight, so we need to record it. This one weighs 2.881 pounds. The weight of the aggregate and the asphalt emulsion in that same plate now is 4.919 pounds. So looking back at that sheet, we can complete it again to calculate the application rate for the aggregate. So what are we doing? We're taking the asphalt and we're needing to subtract it out from what the aggregate to just specifically look at the aggregate weight itself. So let's go back to the bottom part of that sheet. D, that's got that pan or plate with the asphalt and the aggregate in it. That was 4.919 pounds. C is that same plate without any asphalt or emulsion in it, and that was 2.881. And then B was that first plate with emulsion on it. A was that same plate before we applied any emulsion. And when we do all of our orders of operation, the difference there is 0.162. We add, subtract, add, times, go through all your steps. You're basically at 17 pounds per square yard. So that's what that chip spreader, now that we've checked its calibration, is applying chips at. 17 pounds per square yard. So what else can impact our application rates? Well, our asphalt distributor speed. So things that you need to know is what's the speed of the distributor, maybe in feet per minute or miles per hour. You also have to know the output in gallons per minute. So what's the spray bar spraying at? How wide the roadway is. What's the application rate in gallons per square yard? So needed equations. So speed per minute is just 9 times the spray bar, gallons per minute output, divided by width of the road, and application rate. If you're doing in miles per hour, it's still 9 times that output, but now we have 88, and that converts it from feet per minute to miles per hour. The 9 just converts us from feet to square yards, And then the spray bar output, again, remember, is gallons per minute. So all these things can get converted over. But you need to know these. If you look in Appendix B of your manual, it walks you through these. So what do you need to know? All right, so we're looking at it. We got a distributor that's spraying 22-foot wide road. The TAC application rate is 0.3 gallons per square yard. The spray bar output is 150 gallons per minute, so that's what it's able to do. So what's the required distributor speed in feet per minute to achieve 30 or 0.30 gallons per square yard? And what's the required distributor speed in miles per hour? So, output in feet, 9 times the spray bar output, which is 150 gallons per minute. The width, we're spraying it at 22 feet wide, so we got everything extended, and our rate is 0.3. So what do we have to be spraying at in feet per minute, or how fast do we need to be going is really the question. How fast does this operator need to be driving the truck to hit that 0.3 gallons per square yard? Plug it all in. Basically, he needs to be driving at 205 feet per minute. As we all know, some vehicles don't have feet per minute speedometers in them. They got miles per hour. So let's take that same equation and let's determine how many miles per hour they need to be driving. So we still have our 9, our spray bar output of 150 gallons per minute. 88 is our conversion to get us over from feet to miles and minutes to hours. Width, 22, rate, 0.3. So let's plug everything in, and you should come up with 2.3 miles per hour. What that truck, that distributor needs to be traveling at to hit 0.3 gallons per square yard. Make sure you confirm your application rates out on these projects. Multi-step, you need to sum up all your weigh tickets for your aggregate from your contractor. You need to calculate the area treated with the surface treatment. You need to subtract any unused aggregate and stockpile waste. And you need to determine the final application rate in pounds per square yard. So you need to go through all these steps to make sure how many tons of aggregate were actually used on a project. Because not everything shipped is used. So you need to know how much was actually used out on that project to get the total or the correct amount of application rate. You may say, how in the world do we know how much aggregate was unused or still stockpiled? There are ways to do that. We'll touch on it in just a moment. But let's look at, here's Route 608. 3 miles long, it's 20 feet wide. We did a modified single seal. Per the spec, we're using 8P aggregate at 15 pounds per square yard. How many square yards of modified single seal should be applied? If you do the math, it's just 3 times 5,280 times 20 feet wide divided by 9 will give you 35,200 square yards. So that's the area that we're looking at. So that's how many square yards is going to be applied to. Contractor, though, gives you weight tickets for 295 tons. Well, wait a second. All I know right now is I got 35,200 square yards and 295 tons. So how do I figure out what the actual was? Well, contractor inspectors now got to go and they approximately determine 12 tons of material wasn't used. What's the actual application rate? Well, we know we had 295 tons of actual delivered material. 12 tons wasn't used, so our actual application rate is pretty simple. We need to remove the 12 from the 295, so 12 from 295 is 283 tons. Multiply that by 2,000 to get those tons over into pounds, and we divide it by B, which is the number of square yards, and that'll give us what our actual application rate is on this project. So plugging and chugging, 295 minus 12 times 2,000, divide that by 35,200, gives us 16.1 pounds per square yard. We've gone through some simple math, how we calculate quantities of square yards, how many tons of aggregate is needed, how much emulsion is needed. We've looked at spray bar, distributor outputs, and speeds. So with all those things, we've confirmed how much aggregate that we actually used, what our actual application rate. If you've got questions, take time, talk to your moderators, ask them any questions. There's some knowledge checks at the end of this chapter. Work on those problems, work on the other problems in the book, and good luck.